This topic is about the R formula and its real-world applications. Now, when do we use the R formula? We use it to combine a sine and cosine function into one trigo function. Usually in the questions, they'll give us the sine and cosine function, and they'll want us to combine it into all these formula that you see on the right side here. So how do we know which one to use? We choose the correct formula based on the order of the trigo function. This means that we will always follow the trigo function that comes first, given in the question. For example, if the question gives us sine theta first, as shown in the first two formula, then our chosen formula, R formula, will have sine in it. And similarly, if cosine theta comes first in the equation given in the question, then our chosen formula will have cosine in it. Secondly, we must know whether to use a plus or minus sign. Now we just have two basic rules to follow. If our chosen formula has sine in it, then we will follow the sign given. However, if it is cosine, then we will follow the opposite of the sign given. What do I mean by that? Follows formula with the trigo sine function in it, we will be following the plus sign and minus sign. So if on the left side it is a plus sign, then our chosen formula will also have a plus sign. But if it's a minus sign, then our chosen formula will have the minus sign. And for cosine, it is the opposite. So if it's a plus sign, then it's a minus sign in our chosen formula. Then if it's a minus sign, then it's a plus sign in our chosen formula. Now, second step, we need to identify the A and the B, which is very easy because the A is always the one that comes first, and B is always the one that comes second. Now, why do we need this for? So for R formula, there are two components. One is the R value, and the second one is our basic angle, which is usually represented as the alpha sign. Now to get our basic angle, we will use tangent inverse B over A, which is just the second number over the first number. And note that our basic angle is always acute, which means it is between 0 degrees and 90 degrees. Now for our R value, we'll just follow this formula, square root of A squared plus B squared. And therefore R will always be more than 0. Note that these are not given in the formula sheet. That's why we have to know how to derive the formula ourselves using these rules here. Now here's some examples. Express 5 sine x plus 4 cosine x in a single trigo function. Note that this is in degree form. Firstly, we'll have to derive the R formula to use. We'll see that sine x comes first. That's why our chosen formula will have sine inside. And since it's sine, then we can just follow the plus or minus sign that comes with it. So the question gives us a plus, means we'll also follow a plus sign. Second step, we have to identify our A and our B. So A is just the first number, 5. B is our second number, 4. And now we have to derive our R value and our basic angle. So R value, we'll use this formula and just plug in our A equals to 5 and B equals to 4. Therefore, you will end up with square root 41. Now, please make sure to leave your R values in its exact form. So leave it in the square root. Don't use like the decimal and round it up or down. Now, for our basic angle, we'll use this formula, tangent inverse B over A. Therefore, it's tangent inverse 4 over 5, which gives us 38.7. Now, for degree angles, round it up to 1 dp. Therefore, our final answer is root 41 sine x plus 38.7 after you sub in your R value and your basic angle. Now, second example, express 3 cosine x plus 5 sine x in the form of r cosine x minus alpha. Note that this is in radian form. So since they already told us the formula we need to use, which is r cosine x minus alpha, we can just skip to the second step of identifying our a and b, which is 3 and 5 respectively. Now we can just find our r value, which is the square root of 3 square plus 5 square, giving us square root 34, and our basic angle tangent inverse b over a, so 5 over 3 to get 1.03. And since this is in radian, we'll round it up to 3SF instead. Therefore, subbing in our values of r and basic angle into our formula, we'll get square root 34 cosine x minus 1.03 as our final answer. Now, some schools require this presentation. This presentation is basically just kind of a proof of how we get our basic angle and r value. So firstly, we'll once again use our given equation to derive our chosen formula. Sine x comes first, therefore our chosen formula will have sine. And since it's sine, we'll just follow the plus sign given. So plus sign here means plus sign in our chosen formula. And from here to the next step, we are basically expanding using the addition formula that we can find in our math formula sheet. Now, by comparing the coefficients, we'll be obtaining two different equations. What does this mean? So, let's say on the left hand side, the coefficient of sine x is 7. And on the right hand side, the coefficient of sine x is r cosine a. Likewise, on the left hand side, the coefficient of our cosine x is 3. And on the right hand side, our coefficient of cosine x is r sine alpha. So we can equate these coefficients to each other. That's why we will get 7 equals to r cosine alpha and 3 equals to r sine alpha, which forms our two equations. Now if we do equation 2 over equation 1, we'll see that it's r sine alpha over r cosine alpha is equals to 3 over 7. From there, the r will cancel out, which leaves us with sine alpha over cosine alpha. Sine over cosine is equals to tangent, so you get tangent alpha equals to 3 over 7. And then to get our basic angle, we'll get tangent inverse 3 over 7, which is our b over a. And that's how we derive our formula for our basic angle. And then for our r value, we will do equation 1 square plus equation 2 square. Why? If we see from here, equation 1 square means you get r square cosine square alpha plus r square sine square alpha equals to 7 square plus 3 square. Now you can factorize out r square from the right hand side, which will leave us cosine square alpha plus sine square alpha in the bracket. Now if you recall from your trigo identities, cosine square plus sine square equals to 1. That's why you're left with r square equals to 7 square plus 3 square. Therefore, you get your r value by square rooting the sum of a square plus b square. So this is your basic angle, and this is your r value. Now subbing it in, you'll get your final answer for root 58 sine x plus 23.2 degrees. Now moving on to example 10.5a, where we use our formula to solve equations. And note that solving just means you're finding for x. So solve 5 cosine 2x plus 3 sine 2x equals to 0.7. So we can identify our a values and b values. So a equals to 5, b equals to 3. In order to derive our chosen formula, since cosine 2x is in front, our chosen trigo formula will have cosine in it. And since it is cosine, the sign will be the opposite. So in our question it is plus, means in our chosen formula it will be minus. Now we can use the formula to get our r value, which is the square root of a squared plus b squared. You'll end up with square root 34. And to get our basic angle, tangent inverse of b over a, which is 3 over 5, to get you 31.0 degrees, rounding to 1 dp. Therefore, subbing back your r value and basic angle, you get square root 34 cosine 2x minus 31 degrees equals to 0.7. Now you're trying to solve for x, right? So your work doesn't end here. You need to bring the square root 34 over, so you divide both sides by square root 34. And from then on, you'll find your basic angle of 2x minus 31 degrees. And since you're finding x, you need to first find the basic angle of 2x minus 31 degrees. So you do cosine inverse, and you get your basic angle of 83.1. Now whenever you do this kind of trigo questions, right, you need to first find the range of what your 2x minus 31 can be. Since our x has to be between 0 degrees and 360 degrees, then 2x will have to be between 0 degrees and 720 degrees. And then minusing 31 degrees on both sides, our 2x minus 31 degrees has to be between negative 31 degrees and 689 degrees. Because this value is a positive value, looking at our ASTC, the quadrants that this angle can be in is the first quadrant and the fourth quadrant, because these quadrants are what will give us a positive value for cosine. Therefore, the possible values of 2x minus 31, which lies between our range that we found just now, will be firstly our 83.1 degrees, which is in our first quadrant, and then from using this basic angle, we have to find the angle in the fourth quadrant, so 360 minus 83.1. And because our range extends all the way up to 689 degrees, we can plus 360 to our angles. So 360 plus our basic angle, so this is our angle in the first quadrant, plus 360, and then 360 plus our angle in the fourth quadrant. Therefore, you end up with 4 possible values of x. Now, there's a very important thing to note here. If our sine and cosine function is equated to 0, we do not use the r formula. We just form tangent x. How do we do that? So, we'll just carry the cosine x over, then we'll divide both sides by cosine x. The left hand side gives us tangent x, which will equals to 2. Then we can find x by doing tangent inverse 2. We only use our formula when our sine and cosine function is equated to k, where k is a non-zero, so any other number except 0.